Okay, I mentioned this briefly yesterday. Uh, but we're talking about arc length and sector area right now. So, you guys remember what a sector was?
Section.
This was your class, I mentioned this yesterday, wasn't it?
Yeah.
Okay, a sector is like a piece of the pie, and an arc is a piece of the circle. The circle is just this thing, not the stuff inside. So, the arc is like the crust, the sector is like the pie, and
That's the rate.
okay, that's the radius. They call the central angle theta. So we're gonna have to do degrees and radians like yesterday. And I think this book uses S for the arc length. I don't really like using S. I think I'll, man, look how good that circle is. Pro.
Be ashamed. That's a nice circle.
Okay, so sector area would be like how many square units fit inside this piece of pie. A sector area would be a fraction of the entire circle area. So let's start with, I forgot how I always wrote a table, but I forgot how I did this. How did I do this? Now let's do it separately. The circle area is what? How do you find the area of a circle? Pi r squared. Okay, so sector area, you do pi r squared, but you're only going to be using a fraction of that circle. What fraction of the circle we're using? Depends on what theta is. So the bigger theta is, the bigger the fraction is, but it's basically theta over 360. That's what fraction of the circle you're using. If theta were 360, if theta were 180, that would be like half the circle, so you'd be like multiplying by a half. 180 over 360 is a half, for example. Okay, that is in degrees, but we also need in radians. So, here, let's do this. For radians, it's pi r squared times theta out of, instead of 360, what's 360 in radians?
2 pi.
2 pi. So, but this is going to simplify a little bit. This is kind of why they made radians. You guys know how this is going to simplify? So I think the book puts like 1/2 r squared theta. I don't know, or maybe r squared theta over 2. So I'll put, I don't know, which was easier. You guys like times 1/2 or divide by 2?
Divide by 2.
Yeah, that's probably the one I prefer. So in radians, it's a little bit simpler. Sector area. Okay, and then the arc length is a fraction of the what? This is where we got sidetracked with Sam yesterday, huh?
Circumference.
It's a fraction of the circumference. Okay, so what's the circumference formula?
I'm not gonna do it.
You guys remember circumference? Mentioned it yesterday.
Pi squared.
No, that's circle area. Okay, diameter times pi, or 2 times radius times pi. So, arc length is only a fraction of that. So in degrees, we're kind of still using this. It's 2r pi times the fraction, theta over 360. Okay, which does simplify a little bit. The 2 and the 360 reduced to 180, so it's I don't know how they read it. Higher theta over 180, maybe. You know what? I'm not gonna reduce it. It'll probably be easier to remember if we just leave it alone. So let's just leave it as 2r pi, because that's the circumference. You guys don't even know the circumference formula, so I'm not sure that'll help you. But times theta over 360, the fraction of the circle.
And how'd you take out pi again? Wait.
I didn't take out pi.
Why isn't it r squared anymore?
Because, okay, sector area is a fraction of the circle area. This is the circle area, this is the fraction.
Mm-hmm.
Arc length is a fraction of the circumference. There is no r squared in the circumference.
Okay.
This is the circumference formula. This is the fraction of the circle we're using. Okay, and then the radian one simplifies a lot. I don't know if you guys remember this from yesterday, but radius times theta. It's like 2r pi times theta over 2 pi, and almost everything cancels out, so it's just radius times the radians will give you the arc length. I kind of suspect this is why they made up radians, because it makes the formulas simpler, especially that one. Arc length. Okay, number 1. So it says find the length of each arc. So that means we're down here doing the second one. Probably should have wrote that on the whiteboard, but maybe a little later. So we're supposed to be using the 315-degree arc. Not that little piece of pie, but like almost the whole circle.
Yeah.
So, and we're in degrees because it said 315 degrees. So I'm using this formula. Circumference of the circle, what's the radius on this one? 11 feet times pi. Now you might just not plug the pi in here. You might just put it in your answer. Because I don't want, it does say round to the 10th place. Usually we just leave pi alone and put it in the answer, but sometimes they do the decimal. Yeah, okay, we'll plug it in the calculator. Okay, what's theta on this one?
11.
No, 11 is the radius. Theta is what? 315. So we're going to be multiplying that by 315 over 360. Yeah, just plug all that in. And the directions say round to the 10th place. First, yeah, let's see. Alright, anybody get it?
60.5.
Yep. 6.5. Okay. I don't know if I'm going to do all these. It's too much repetition. Maybe I'll just do a couple from each section. Number 3, what's different about number 3?
It's in the breadth.
It's in radians, yes, because the angle, they say the angle is 3 pi over 2. So that means we need to, and they kind of jump back and forth on this worksheet. So that means we need to use the radians version.
So is it 16?
So it's just 16 times 3 pi over 2. So sometimes they just want you to put 24 pi, but this worksheet does say round to the 10th place, which tells me they want you to multiply by 3.14 by pi.
75.
Point.
4.
Oh, okay, number 9. I got it. Number 9, they're doing that.
Oh.
All right. On number 9, it's the same as number 1, except for they want the answer. It says do not round, so they want you to leave pi in the answer. That's the difference. So we're still plugging it in the same formula, but you don't really need to plug the pi in because we'll just leave pi in the answer. So 8 is the radius. 315 is the angle. So I'm using the degree formula. Let's see, what would that be? Like 7/8. I think it's 14. But it's actually 14, because I didn't put pi in there. It's actually 14 times pi. So yeah, it's just almost the same thing. Some of your calculators, if you plug pi in, they might leave it in the answer, so I guess you could plug pi in. Some of yours will probably just make it a decimal. Kind of depends. Okay, so on 11, same thing, but this time it's radians. The angle is pi over 2, like 90 degrees. So I'm going to do the radius for 11, which is 14 times pi over 2. We don't need a calculator for this one because 14, yeah, it's just 7 pi.
Is that pretty much all you do for the rest of the page?
No, well, no, that's arc length. The back page is sector area. So, sector area formulas are a little bit different. You do the area of the circle times the fraction. So there's just a little bit different. So you do circle area times the fraction and circle area times fraction. That one simplifies. Okay. So on 13, we're going to plug in 10 for the radius. Make sure you square it on these. And we are doing the decimal version on 13 through 16. And I'm going to plug in 60 for the angle. You guys know what 60 over 360 reduces to? 1/6. So you could just plug in 1/6 right there. But because we are doing the decimal, you do need to plug in pi and make it a decimal. Comes out to about 52.4. You guys remember how to label areas?
Inches
Squared, yeah. Okay, 15. The radians version is r squared theta divided by 2. So the radius on this one is 4. And the angle is 3 pi over 2. Like 270. And not, or yeah, it is, this one is squared, 37.7 inches squared. Okay, 17 is the same thing except for you're supposed to leave pi in the answer. It says do not round, that's how they say it. A lot of books say write your answer in terms of pi. This just means leave pi in there. So the radius is 16, so 16 squared times 240 out of 360. We're just gonna throw pi on there. I don't think I can do that in my head.
You can do it.
Yeah, it's too much.
170?
Is it 170?
170.6.
No, we're leaving pi in the answer, so just plug that part in.
It's 170.
Oh, yeah, the book wrote fraction, that's why. Yeah. Okay, yeah, they wrote 512 over 3 pi. Okay. And then 19, same thing, but with radians, so I'm gonna use this formula. 14 is the radius. 3 pi over 2 is the angle. Well, okay, you can just kind of throw out the pi for a second. Divided by 2.
I got
147
Yeah.
pi. Alright, clear as mud?
Yep.
Maybe I'll check your like 2 and 10 and stuff.